8.3 is on composite functions. This is another way of combining functions where you're not really adding, subtracting, multiplying, or dividing any of the functions together. You're actually substituting functions into each other. Okay, and I know that sounds kind of weird, but it's actually not that hard. Okay, so I'm going to show you this video, which is a lesson, and then another video, which is on examples. All right, so let's start off with the warm-up. What you're going to do is determine the inverse of each of the following. So this is like a grade 11 type of question, and we're just going to review a little bit. So the first step is replace the f at x with a y. Then you can easily invert the x and the y. Okay, so actually these two steps right here are your original f at x. They're equivalent steps, but the third step is actually not equivalent to the two above because you've already switched both of these guys together. So this is already starting the inverse process. All right, so the next step is to solve for y and isolate it. Bring the negative 4 over, it becomes a positive 4. And now that you have y all by itself, that is the inverse function. So your inverse function is x plus 4. All right, let's try that one more time. Replace the g at x with your y so that you can easily see where you're going to switch the x and the y together. So now this step is the beginning of the inverse. Okay? Solve for y, we're going to bring over that 1 first because it's really far away from the y. The 3 is more attached to the y through a multiplication. So the 1's going to become a negative 1, and then we're going to divide out that 3. So our inverse function is x minus 1 over 3. Okay, so we're going to be using these a little bit later on in the next video. Just keep them in mind. Let's explain composite functions now. Okay, so basically what a composite function is when I substitute one function into another function. Okay, so this is read as f of g at x, or f of g of x. It's the same thing. Now if I want to write them together, I would actually write f with a little circle, that's not an O, and then g, and then an x. Okay, so this is how we actually combine them, and this is how you're going to see it. It is said as f is composed with g, but no one ever says that. I think I usually use this one, f of g of x. But there's an even easier way to say this that my high school teachers actually said, and they always just called it fog. So find fog, that's what they said. Okay. All right, so this is what it actually means. This is what fog is, all right? So you're taking an x value and then you're putting it into your g equation, okay? And it's going to create a new number, all right? So this should be like your y value of your g at x. So let's say I took a 3 and then I substituted into the equation and it spit out like a 5, then that's going to be your y value for g. But the thing is, now that you have that 5, that y value, it actually becomes your x value because you're going to sub it into another equation. So you're basically putting that into this other equation, and then it's going to spit out another y value. I know that's kind of confusing, but that's what fog is, and we're going to explain it a little bit later on as well. I'll try again in a second, but let's kind of show you like an application. All right, so let's talk about maybe a forest fire. A forest fire's area, let's just pretend that it's circular, has a certain radius to it, okay? And that radius really depends on the amount of time the fire has been burning for. Okay, so let's just think about it. Like, let's say it's burning for 3 hours. That 3 hours, when you put it into the radius, is going to create maybe a radius of 5 kilometers or something like that. And then that 5 kilometers might be put into another equation that tells you about the area, the full area of the entire fire. Okay, so do you see how like the area of the fire is really dependent on the amount of time that the fire has been burning for? Okay, so that's basically what they're saying. Like T is going to go into R, which goes into A. So A is dependent on R, which is dependent on T. Okay. So here's the last slide that I want to explain to you, and maybe this is another way that I can explain it that may make a little bit more sense. Whatever you're inputting into your G is going to be called your domain, right? Your X values are your domain. Once you put it into G, it spits out a number, and that is your output, which is your range. Well, that range is also the input or your domain of your f, because as soon as you put that number into the f equation, it's going to spit out an output, which is the range of f. Okay, so it's just like step by step by step. So I hope that is kind of not that confusing, but I'm going to show you through examples in another video.